Hello and welcome to a new series. Nah, it's not a series, I guess. We're gonna do a little live work session here today, and today we're enabling Golioth Bluetooth-to-Cloud on some new hardware. We've already done this on Nordic and NXP. Today, my good friend Mike here is going to show us how we do this on the STM32WB5MM-DK. Hey Mike, how you doing?
Yeah, I'm doing pretty good. I think I'm excited about this because I often hear people, they're like, oh, I did this and then did that and you did that. And they're like, can you just like show me how you got from point A to point B? And so we're going to be doing it with a bunch of different boards. We just grabbed this ST board as our first one to get started on the Golioth BLE private access program.
That's right. And, a lot of this is based around the fact that we build on top of Zephyr. The Golioth Bluetooth SDK is built on top of Zephyr as well for now. And that means that things that have Bluetooth compatibility within Zephyr, in theory, should work with our stuff. And we're kind of proving that out live as we go. And that, we're just going to bring people down the path with us. So if you have any questions as you're watching, we are going to be watching the chat here. You can drop some questions in. We'll try and answer them as we can. We should be broadcasting on both YouTube and LinkedIn now. And if you're watching this after the fact, you can always ask us questions over on the Golioth forum. That's forum.golioth.io. All right, Mike, where should we start?
Well, I think we should start by talking about what the Golioth BLE private access is all about.
Good question. Yeah, good point. What do you got for us, Mike?
Well, I think you're the one that's been talking about this the most, but I always think of it this way. We at Golioth support any IP-based devices, so Internet Protocol, and through a bunch of different stuff like cellular and Wi-Fi and Ethernet and even Thread, because that's IP-based. But what we've had a lot of requests for are Bluetooth devices, and that means using a gateway. And so we had a great team over on the engineers squad at Golioth who put together firmware for a Bluetooth gateway device that uses cellular, and then leaf nodes that connect to that Bluetooth device and thereby connect to Golioth. So your IoT fleet that's Bluetooth based, you can go and hit the internet, get data to and from it, just using one of those gateways.
Yeah, that's a good point. The only distinction I'd add is really that is based on it's made to be more generic for non-IP generally, but Bluetooth is the name of the game. That is the most requested thing that we have, like you said, the most requested thing that we do been asked for, and it's we've already seen so many cool new devices that we get to talk to and have talk back to the internet through this. So yeah. This is also the topic of the Orleone board, the AirTag clone series that Mike and I have been working on as well. There's some custom hardware we've been doing here. We enabled last week that with Pouch and the Bluetooth-to-Cloud capabilities. And now we're just going to show this on yet another device.
Yeah, and so we picked this STM32WB5MM-DK, which is not in focus because the camera doesn't do that apparently. Sorry, folks. But we picked it, let's see, because it has support in the Zephyr tree, but we haven't worked with it, and technically Golioth doesn't support this. Like, it's not one of our verified boards. It's not something we've connected to Golioth before, so we're gonna do that today.
Right. Yeah, I think the only way you would have been able to get that working is if you had like a secondary modem, like an ESP32AT, ESP-AT based like Wi-Fi modem attached to it or something like that. Then yes, in theory it could work, but it's not something we're regularly testing.
Yeah. So if you want to try out Bluetooth private access with Golioth, you can totally do it. There's a bunch of blog posts about it. The page that I'm on right here is GitHub Golioth, and then it's a BLE private access repository. So BLE private access right up here. And there's a link that says apply here on this form. And we'd love to help you through that process if you just want to try that out. Our end goal today, so I already have a gateway running that's running on a Nordic NRF 9160DK, which has a Bluetooth chip on it as well as a cellular chip on it. So it's scanning for devices. But this repository we want to put onto our STM32 board. And the first thing that I do when I'm looking at a new board with Zephyr is go to the docs and look through as much as I can from the docs here. And I think that's how I figured out that you need a programmer. That's something I figured out last week. I was just going to try and run Blinky on this. And let's see what it says. Yep. So right here, the default programmer is STM32 Cube Prog. And that you can click through all these links and you get to where you can download the software here. And the nice thing is it does have a Linux version that operates on the command line, which is usually what I'm looking for. And so I got that. I was not able to run Blinky. I was talking to Chris about this earlier. I don't think that it has the magical LED 0 or whatever alias it is. So you could definitely alter it to run Blinky. But if you're just going to get it to run something, try the Hello World. I was able to get that running on here. And I thought, great, we're ready for the live stream. Except during lunch, Chris, I got nervous. Because I was like, I bet you have to download some binaries to make Bluetooth run. Because most of the Bluetooth devices that you use, like ESP32 or
actually all of them, I think
maybe all
even
of them,
like
yeah.
our gateway has also an HCI driver on it as well, in order to basically be a controller for the Bluetooth radio that's out there, all the stack, all the things like it. And then there's so like on our gateway firmware on that NRF 9160 or 9151, that is controlling the Bluetooth modem effectively through the HCI interface. And so it's doing the same thing. So and this is like the interface layer for a lot of different Bluetooth things.
Yeah. So usually you need to run like West blob fetch expressif or something like it's some West blob fetch command.
Yeah.
For whichever, I think what did I run it for? The Freedom board? What is that? NXP? I've had to run it for the NXP. Like it's just general thing. You're going to need some binary. And so I got Chris on the phone and he read the documentation. I guess I still haven't read the documentation.
Hey, you know what, Mike? There's a first time for everything.
Yeah. Right. So this is still on the board definition in Zephyr, and it says right here, to operate this, you need to have the coprocessor binaries, either the full stack or the HCI layer binary. And that ended up being kind of a rabbit hole. So it does send you over to this repository right here. And then this repository tells you that it got some files from the main STM32WB5MM-DK repository. And we ended up finding this entire list of binaries. So what you need to do then is like figure out which binary is for me. And in our case, there is a release notes right here, which is in HTML format. Actually, not very easy to read.
Is that the one you want? That's for the entire STM thing. I think you actually wanted to go back to the release notes in the list of binaries. So this one is a little different. Yeah, this is for all.
Well, at any rate, you can find your own release notes.
Oh no, Mike, show me do it. Oh, that's so mean.
Oh, is it in here? Oh, it's right in here.
Yeah. So that has its own. Okay. So this is the directions on how to load it up effectively, and that is very very important.
But not very readable. So I did copy that to my local drive and then just open it, and it becomes a little bit easier to read in here. And honestly, like I'm not going to dig through this, but it does tell you so we looked at our FUS. Let's just do this. So when you install those tools, let's see, where did it go? Right here. Nope, it's in 6. There we go. When you install those tools, you actually do get the programmer GUI, even though it also has the command line tools. And so I just opened it. It kind of looks like this. I clicked connect and it managed to find my board, except then I got an error here. And that error was something crazy. When you go and you look in the binary files here, there's one called Flash Loader, and let's just, for the fun of it, let's remove our file that we use for this. All right, so when you first connect, it's going to give you this error right here, which is like, okay, it can't find the loader, and it's looking for the loader at 0x, and I have no idea why. And so we found a Stack Overflow that said what you need to do is copy the file that correlates to your chip ID. That was 495, right, Chris?
That's right. Yep.
So I want to 0x495. There we go. I want to copy that into a file called just 0x. And then I won't get this error and it'll actually be able to find it. All right, wonderful. So we're connected. We didn't get the error. And then you have this firmware upgrade services option. And so under the firmware upgrade services, I think we were looking through this list here and we found that we found the release notes. We looked at the release notes right here, and the release note says check your FUS version. And so you can read FUS infos with this button right up here. And it's reading it right now. And I think that's firmware update system is what it's called. We're at version 2.0, but originally we were at version 1.2. And so it tells you then you must go to step 7. And step 7 then says, go find this file, which is the name of our chip, FUS firmware. So if we go back to this repository, we downloaded this file, we loaded it up here, wherever this is, this one right here, and it picks the starting address for us, which is nice. And then you click the firmware upgrade, which will take care of itself.
A bootloader for the HCI service area, right? Of the memory. It's got to be something like that.
Yeah, it's handling writing to maybe different cores or different parts of protected memory or something. It's doing firmware update service. So the firmware update service is now upgraded to 2.0, and then that allows us to go and actually follow the directions for
step 8.
I think we even just didn't do step 8 because it was the coprocessor.
No, that's right.
I'm not sure.
No, it said now you can basically download the binary for the HCI, like
right.
Before, so
yeah. So we then downloaded the HCI.
Just so we're clear, we're saying all these steps. So if someone is to follow along in our footsteps, you have to do the same stuff. If you want to have, otherwise the samples that Mike was running, they say, hey, I don't know what I'm talking to here, right? It's an application side talking to the HCI core, and it says, I don't know how to interface to it. So
basically I can't find the Bluetooth hardware without this. So we tried both of these, and I'm running the extended right now, and it seems to work fine. The extended did not work for the Bluetooth beacon sample in Zephyr, so we used the regular one for that. But at any rate, I found my HCI layer firmware. Let's say it's the extended right here. I'm not going to click the firmware upgrade because it's going to take like a minute to do it, but it will do it. And then click the disconnect button, and then we're done.
Mike, I think I lost your audio on this, unless it's my headphones.
Did you lose my mic?
I did, yeah.
Is it back or is it the wrong one?
It's the correct one, yeah.
Okay, great. Sorry about that.
That's okay. I thought it was my headphones, maybe. Mike and I have been playing with Bluetooth stuff for like, oh, my headphones are gone. Oh, no. This is connected. That's connected. I can do it on my mouse. It's like the downsides of working in Bluetooth development. It never happened with cellular, It wasn't like, oh, my phone can't connect to the network now.
Yeah, I was scanning. When we were trying before, I was scanning Bluetooth and my ears kept cutting out. All right. So a bunch of preamble. We're sorry we pre-gamed this one, but that was like 45 minutes of troubleshooting that you didn't have to. You only had to live through 14 minutes of it.
Yeah. And I think, one thing to point out as well is that so ST's primary path, they're doing more Zephyr stuff, but their primary path is Cube, right? So if people were using Cube, that's going to probably be a little bit smoother, but we're using Zephyr because of this compatibility layer. So this is the stuff that we did to kind of work around it. But now it seems to be working, which is great.
Yeah. So we're back to our Bluetooth private access, which is awesome. And if you go through all this stuff, it's going to talk to you about preparing a gateway. I have the gateway already prepared, so we're not going to do that. And eventually it's going to talk to you about building our application right here. So I've done this, and I'm actually running on the NRF52840DK right here. And we can see that in our networks tab. Here's my 9160. Here's the currently running node. Here's a node that I connected a long time ago and I haven't turned on since. And we're going to add another node today. So basically we just follow these instructions. And the first thing that we're going to do is create, it says a second device, but in this case, we're going to create a third device. So under my, this is the web console for Golioth at console.golioth.io. And I'm just going to go ahead and create a new device. And I'm going to call this one STM32WB5MM-DK. Is that right? What a mouthful. And auto-generated. Yeah, that sounds good. So we're going to add that. Done. And then we are, what was that?
You need the device ID now, I think.
Yeah, I need the device ID. I was just thinking about the order in which to do this. I'm actually going to copy this command first. So we'll tell you when you set this up, make sure you update your submodules, and then this initialization will set up the repository itself, and then this will fetch the dependencies. So if I go right into, do I need to be in pouch? No, I think I just need to be right here. All right. And then we're going to grab this build command right here. We're going to first paste that build command. You'll see there's this replace me part at the end of it. Let me make this bigger because this was doing split screen stuff before. That replace me in the instructions tells you it wants the device ID. So from the devices tab right here, I have my device selected and I can copy the device ID. Let's delete that out. And then we also need to change
that into the project.com for something like that, right?
What was that?
That's so you don't. The reason we're passing the dconfig on the build line is so we don't put it into the project.conf and put it into revision control, like I've of course already done 3 or 4 times personally.
Yeah, you could have several devices identifying themselves as one device, which is not going to be great.
Yeah, right.
And then this is STM32WB5MM-DK, like that. All right, so there's our build command, and this is going to fail. And it's going to fail because it's looking for STM header files or like device tree files. And we don't have those because this repository was set up to not have them. So if I go in and look at the pouch repository, there's a manifest file called west.yaml in there, and it uses an allow list. So what that's saying is only get the things that are on this list. And so you could go to the Zephyr repository and look at what different HALs are available, but I just happen to know that it's HAL STM32. So I need to put that in there. And then I need to do a West update, but I'm going to do this one right here that is the depth 1 because it won't try to download the entire internet.
This is my new favorite West command, actually. I use this all the time now. I don't know how I survived without it for so long, honestly.
Yeah, I think I should put an alias on my computer that like WU runs this command instead of West
I like
update.
it. Yeah. Although when did I get pinched by this recently? There was something where I actually needed to have the whole history. I think it was, I was trying to do a detached head back to a previous version. And because I didn't have the full history in Git, it's like, I don't know what that is. And so I ended up having to down. I probably could have done a narrow again, but it didn't know how to find the older version, basically.
Yeah, I'm not sure exactly what the depth 1 does, but I think it doesn't grab anything prior to the current version. So you don't get, like the huge history you normally get is just not there. But you can see
every time there's a binary that gets deleted later, it's like still in the history that you're downloading, right?
Yeah, you can see from this block, I did just grab the files I was looking for. So now I can run my command again. I don't technically need to do a pristine build, but I'd like to show off how fast my computer is since I upgraded the CPU and RAM. Look how fast that was. That was really fast. And then, so that was this command right here. And then the last one is just flashing it. And so, oops, West flash. We'll go ahead and do that. And the device is flashing. And
one thing that's interesting here too is the because it has a different runner setup, it's running with ST-Link. And that's one that I don't normally see. So it looked a lot different to my eyes, where I'm used to like NRFJ prog or similar.
Oh, you know what? I'm on the wrong device. I have several devices plugged in right now, so it's probably
More flex from my computer's so fast. I got so many devices. What's
yeah? Let's see if it's this one. It is this one. All right. And then, do I need to do anything? Oh, interesting.
like a segfault to really.
Yeah.
We're gonna see it work. Maybe we have to reload the binary. Did we
I
end
might
up switching
need
those out?
I might need to reload the HCI because I deleted all the flash on this chip. So
Oh, I bet you do. Yeah, I don't know.
Whoops.
That's okay.
All
We
right,
have to
so
show
let's
it
just
then.
get out of here. Yeah, that whole process that we were showing you before, we're going to actually do, even though I said we weren't.
Yeah.
All right, so let's do the extended because we can.
And this should work because you already have the firmware update service updated. So now we're just a straight ahead thing. So again, if people jumped into this point, you would need to have the FUS updated in order to make this work.
Yes.
And that's that release notes thing.
So the first message said that it deleted the firmware, and now this message says it upgraded the firmware. And then important step, click disconnect, otherwise you're not going to be able to flash the chip. So let's try and flash it with our Zephyr again.
It's so fast.
I know, it's incredible. Again, I got to get the right port. All right, let's see here.
I just try every ACM and I keep hitting reset until I see the one that synchronizes with my button press.
Why you no work?
Yes.
There we go. Advertising started successfully. And then we should see the gateway query the device shortly. So the problem there was we didn't have the binary, the Bluetooth binary flashed on. I had erased it from my previous work to make this look like it was new. All right, so we did get an error reading a remote feature. But if we look at our networks, we will now see that we have two devices connected. One of them is the STM32 device, which let's see if we can get to it here. And we can look at stream data, and we can see it sent us a stream at 152, and my clock down here says 153. Success!
All right.
Harrowing, Chris.
That's funny. Well, Mike, that was fast work to get that working. Should we try and shove in some sensor data now or no?
Yeah. So are there any sensors on the board?
I think there are actually. There is sensors. There's a temp. There's a ST temp one. But then I was looking at the starting. We can look at the board file for it.
Oh, there's what? Hey, there's the VL53 LOX time of flight sensor on this.
Oh, we know that one.
That's crazy. We use that for our greenhouse demo.
Yeah.
And then,
what's the other one? ISM 30. Oh, 6-axis IMU. I'd say the VL is probably a good idea, if anything.
The VL, really?
I think so. It's in the. We can just go and copy the garbage can reference design. Reference
trash can
monitor.
All right.
I think it's in there. Yeah, the overlay.
Like this right here.
Yeah.
All right. So we probably actually hold on. Not there, right?
Is I2C on there? I2C should be enabled, right? If it's not enabled, then it wouldn't.
Looks like I2C is not enabled. So what we're doing right now is looking at what Zephyr lists as being available on the board, and then we're trying to figure out how to turn those on. So I'm actually going to go up here on the upper right. There's a Browse Board Sources button. And then we can go into the board sources. BTS is our device tree file. And we can try and find, what was that? VL53. All right, so here it is right here. And I2C is set to OK. So I wonder why that's not turned on.
Maybe sensors? Maybe it's not turned on in the... Don't you need to turn on I2C in the configuration?
Yes. Let's try that. So I'm going to go in to the pouch example. What did we build? BLE GAT. And I guess let's try turn on some stuff. So
I would turn on sensor, turn on shell, turn on basically everything, right?
So shell's on, but
shell,
let's turn
on
yeah.
I2C shell.
Look how fast it builds, Chris.
It's so fast, Mike.
All right, so we're going to rebuild it, reflash it. Hey, definitely have I2C.
So it was already in the board file. I missed it when you did that. So you're saying the VL51. Oh yeah, look at that.
Yeah, it's definitely already in the board file. And then
Paddle. That's nice.
What do we think the address is? 29. So I see 29 in there, but I don't see the actual sensor.
Remember, do we need to have the initialization in the application code in order to have it show up?
I don't know. I don't think so. No, I think you can just enable it this way. But you know what I do want to try to do? There's something called die temp. Hey, look at that! You can just read the die temp using the sensor.
All right, we can just send that.
All right.
Just breathe on the board, Mike.
What about vref? Look at that.
Well, that's nice.
vbat.
Yeah.
Yeah.
Okay.
But it would be nice to get that other sensor running. So
yeah, the other one's nice because it's got the, you can do the demo where you're like, how far away is my hand? I mean, that is a great sensor. The other thing would be there was some, how else did we have to do that? There was another way that we had to put stuff in there. Okay, so this is an older version in our reference design, but we do have config VL53L0X equals Y in that. I don't think we have to do that anymore. That's an old version, I think, of the
So here's something to look at. So what I did is I went into the builds folder right here, and in build I went to our Zephyr folder, and in Zephyr I went to Zephyr DTS, and that's what I'm looking at now. And so I'm looking at this node, which is where our devices are, and the thing that I see here is like the node is turned on. But this doesn't have an OK on it. So I'm wondering if we need to turn that on.
Things are not OK.
Yeah. So let's try and turn that on and see if that does anything. I don't know. Let's just do app.overlay. So I think it's just ampersand and then.
Oh, I see. You're going to just say status equals OK.
Yeah, and see if that works, right?
Yeah.
And my guess is it will not work. because I got the syntax wrong. Oh, I got it right. Oh, wait, no, you know what? I need to do a pristine. When you add a new overlay file, you need to do a pristine build.
Yeah, because it rebuilds the whole tree and stuff, like how they relate
Yeah, it
to each other.
doesn't look for overlay files. Like if you change an existing overlay file, you don't need to do a pristine build.
Looks like you got the syntax right though, Mike.
Or it didn't pull that file in.
Temp, PLERF. Yeah.
Did it pull the file in? Yeah, it got the file. So let's go and look at.
And you don't want to do config VL53L0x equals Y. That's the old way of doing it, right? We don't have to do that anymore.
Yeah, that should get automatically built in, but we can try it and see if that does it. Let's see. This is what I want. So I have the OK here now.
Yeah.
But it's still not seeing it. So what is that in our reference design?
It is, but that was built a long time ago. Now Marco rebuilt it recently. Well, recently 8 months ago, but it is in there. Like I said, I don't think we need any of this stuff anymore. But like, I remember we always used to put config _ BME280 equals Y, but if it found it in the tree, it just enables it like you said. So, yeah.
Yeah, let's try it and see what happens. And if this doesn't work, let's just use the die temperature.
I think that's right.
Moving on.
Does not appear to come through.
Yeah, that's interesting. I wonder what's keeping that from building.
Do you think there's not like a special library for it, is there? Like something we would have had in the west.yaml? Zephyr network. HAL. Oh, there is a HAL ST in this old one. Actually, I do think it is in there. Try HAL SD in the allow list. Because we put in HAL _ STM32, but I remember before we started recording, when we put in the STM32 HAL, I was like, that's really big. But I remember looking at this HAL ST and thinking to myself, why isn't there more in here back when we did this? And I think it's because it's just the headers for the sensor stuff. I think. Okay,
so here's a HAL ST library right here.
Yeah, I think that's got the sensor stuff in there. It's weird that it wouldn't have thrown an error though if it's trying to find the drivers,
Right.
Come on, no whammy.
Huzzah!
All right. And look at that, we get the accelerometer too.
All right, which means we didn't need really any of this stuff. So like I don't think we need the app overlay. And I don't think we need this.
Yeah.
And let's try it one more time. Just for
that's frustrating though, because it's like if this would have been just me doing this, I would have been like spinning my wheels for like hours and hours and hours and hours. Like there's no error there. That is a little troublesome.
When I'm developing on a new board, I generally don't use the allow list. Right. So like the allow list is more for like a mature project. I have like an installation of Golioth that has every possible dependency Zephyr could have. And it takes, 15 minutes to download it because it's all so large. It's all so many files. It's not that large. It's a couple of gigs. At any rate, did I flash this? I did. And device list. Still there. All right. Perfect. Now, what are we going to do? Sensor get VL. This one.
Over, though. You gotta do that, Mike. You gotta is near. I remember that from the trash can monitor too, because it has the is near was like if it was like too close, it If your hand's right over top of it. No?
It's hard with a split keyboard. Is near.
I guess
No.
not. Okay.
Where?
Well, it's showing
Where?
distance. It's the it's one of the. It's on the top line. There's like 4 sensors at the top of it.
Yeah. And then what else are we reading? Oh, distance. Yeah.
Distance. It's
All
that.
right,
It's
so-
the last value in the parentheses. So it's 0.0229999, or in this case, 286,99999
Yeah.
meters, I believe.
All right. So this should be half that. That's about half that. Yep. And then this should be half that again. Great.
All right.
Perfect. So
It's such a cool sensor. It's like time of flight, so it's definitely like it's basically like measuring nanoseconds. It even shows nanoseconds output. So
yeah, let's see. So
we
where
could just
are we sending?
Mike, Bluetooth. The trash can is now Bluetooth enabled. We could do a series of trash cans instead of just one.
That actually makes a lot of sense.
It does. Yeah. Former customer wanted to do lots of trash cans in one spot. So, and they would be. I think the tough thing would be how often do you take a reading? Put it to sleep for a long time. I guess you only have to know every once in a while.
Maybe it's got a vibration sensor, so every time somebody throws garbage in there, then it takes a reading.
Yeah, or if it like a VOC sensor, so if it gets stinkier, yeah, it's getting closer.
All right, so let's cheat and use this for all of the C code that we need to write. Then we don't have to write any code, which I think is nice.
Yeah.
So we can probably use that, right?
Yeah, this is exactly the method I did when I made the little weather sensor one for mine. So when I was doing this initially, I just went and stole all the code from the old reference design with the BME 280. Although that had a thread as well.
All right, so we get it there, and then we probably need to initialize it. I think it'll initialize automatically. We probably just need to read from it, right?
No, I think there is a function for booting it up.
Is there?
Let me see. I have it here.
So just an is ready right here.
Oh, okay. Okay. Just skip that.
Yeah, so let's see. Event handler. So when we get an event, let's try and read from it. If all right, and else.
While Mike's doing this, I'll go through the comments that I've been not paying attention to, which is many of our own. Jonathan, our CEO, is correct that I love Zephyr shells. Mike also loves Zephyr shells, though. I think that's a fair statement. I think this was Dan sent this. Dan, our CTO, who's also here. He said, "Your disk space, thanks." I think this is when we were doing the narrow pull. So, and finally, Vishal, who's here, decided to come and watch the Zephyr stream despite having an exam tomorrow. So good luck on your exam. Hopefully your exam's about Zephyr and IoT connectivity. Then you'll be doing great.
All right, so I'm copying all of this stuff right up to this one. Lost ya. Okay. Dist in millimeters. Int. All right.
Mike, this is already a killer demo, I gotta say. I mean, like,
Is it?
I think it is.
All right.
I think having a Bluetooth connected distance sensor is like super cool, you know?
I'm guessing that the name of the device does not match. So let's see.
Older version versus the newer version here.
Well, right here we said, okay, you're going to go and find a node label with this, but I'm guessing that that doesn't match, and that's why we get this error. So go back and look in our DTS files. It should just be this, I think. Yeah.
Oh, they got rid of the ST part.
Nope. I'm just gonna remove the build folder and make sure I still get the error, because sometimes that's a problem.
Huzzah!
Mm-hmm.
Label. Device to get.
I can never remember what these things are called. I always have to look it up in this how
Yeah,
to use.
like the different types of like fetching and stuff like that.
Yeah. So node label,
you're saying
serial 0. So this is definitely node label. Sorry, what was that, Chris?
I was just trying to talk through what you're actually fixing here as well. So this is when we're going to look up on the device tree by node label, we're going to go out to the, so device DT get is go out to the device tree, look for this node label, and then pass the handle back through, right?
That's right.
And you're saying the ST underscore VL53L0X that was in there originally, the ST underscore is gone because that's not what it's actually called anymore in the tree.
Yeah. So if we look at the generated DTS file, this is the node label right here.
Got it.
Just the VL54.
Yeah.
But it's not finding it. So it could be. Do we need a Zephyr device?
I
don't think so. I always find these so cryptic.
Yeah.
Like we didn't get a warning above or an error above.
Can you you were looking at the Zephyr DTS, right? Yeah. Okay. There's no other way. I know there's other, instead of DT node label, are there other DT underscore things we can use?
That's what I was looking up here. So we can make an alias to it.
Oh, okay.
But I think we're going to have the same problem if we do that. We could get a path. Here's a path. So we could try path.
Oh, and that's like the hard-coded address there instead, like the one that you look up on device.
Yeah, let's just try that and see.
Sock serial.
I think we still need a DT get, and then oh no, the path here is going to be like, oh no, maybe this is path. Yeah. Okay. So let's put in. Sorry, folks. I'm figuring out what I'm doing here. Let's put in this. So we don't have a node label, I don't think. So there's a node label.
Oh.
And now this should work.
You got to switch it back to the ST underscore though.
Yeah, like this. All right, so let's see if that works. No. Rah! Did I save the file? I saved the file. It's giving me an error. Yeah, okay. Well, that's disappointing.
It's not DT node path, right? Because there's DT path and DT node path.
Oh,
DT node path,
call.
DT node label node.
It should be DT node label.
Node label. DT
yeah, DT node label.
Oh, sorry. DT node path is like how you back calculate the path to that label. So we're doing device DT get. Just think about how reassuring this is, Mike, to other people, though.
Yeah, well, if you take our Zephyr training, I'll tell you, like, this is always a slog. But once you get it set, it'll just stay that way forever.
Mm-hmm.
Do I need to do... I'm wondering if I need an include for the device. I think we get a different error if that was the problem. Let's see. Include generated, Zephyr, device tree generated. And then...
I'm going to read down the list of what's on the reference design template. You have Zephyr driver sensor. Is that right?
Yes, I believe I have that. Give me just a sec to look at this one. Yeah, so here it is. So we've got it here. We just need to, so it exists in the generated device tree. We just need to figure out how to grab it.
And the input to device TTCAT is the node ID.
Oh,
so we're looking at the node ID.
I figured out what I did. I edited a file that's generated. So here's what I edited. Yeah.
And it regenerated. Okay. So you want to do this in the you do an overlay. If you did it in the overlay file, right? It should rename that, give it a label.
I could. We should just be able to grab it right out of there, though. So, you know what I'm going to do? I think we can use this, can't we? I think we can use DT path.
I think so.
So, and the path I think would be...
It would be the I squared C.
You think it would be I squared C?
I think so. Maybe not, though. Oh, sorry. I think it's still sock, and then I think it's I squared C underscore I squared C address. No?
I see what you're saying.
No, we could do in the short term too. Like, this would be very short term, because we could go into the board file in your Zephyr dependencies if you really wanted to, and then just edit in there and give it a name, a label.
Yeah, but I can't do it, Chris.
I know. It's not the right way. I'm not saying it's the right way.
How did they get this? iSerial. I think it's this with an underscore here, and it's going to be I squared C3. Is that what it is? Oh, terrible. All right. Let's do the bad thing then, Chris.
Just unblock.
All right.
We're not saving this in the
boards STM ST.
Although if we just did an overlay, shouldn't we be able to just copy the stuff out of the ST into an overlay and then it would relabel that? Or no?
Maybe. Let's try it.
Like if you look at the actually, yeah, look at this. So if you look at the reference design trash can, it actually has the label built in there too. Do you have that available by chance?
The trash can?
Yeah, go to the elixir_ns overlay. So just copy that node and then add change it to, instead of microbus_I2C, make it I2C3 in your overlay file, and that should do it, I think. And then you could also, I mean, we put in the status okay there, but.
What, I can never remember. This is a terrible one. WB5MM-DK overlay. All right. I2C3. Like thus?
I think so. And then as long as it's referring to that. Oh my gosh.
Huzzah! All right, that was ridiculous. Thank you, Chris.
There's one thing I'm good at, it's copying other people's work.
Now watch it seg fault.
Yeah. So I didn't see when you were writing. You were writing in the pulling out that code as well, like the distance code.
Yeah, so it's just going to print the distance. All right, so there it printed the distance a couple times, it looks like. So now we just need to send that distance.
Oh, cool.
Let's see how we want to do that.
That you could probably copy from the reference design again as well, right?
Well, I think we can just take out the temperature and send our.
Yeah, when I've done this, I usually copy this entire, or I usually comment out this entire pouch uplink and uplink entry and close. And then I enter my data in there.
So are we replacing it or are we doing two?
I commented out so I can always go back.
All right, so like that, and then, wait a minute, this is not the right place. Up here.
Why not?
Okay, all right, so we got our reading, great.
Yep.
And then here we want to do something like char my buff, or let's dist buff. And let's do, I don't know, what do we need, 48? Probably not that much, but that's fine. And then sn print k, and then dist buff, size of dist buff, and then basically this. That didn't do it. Disk percent. What is that? D?
It's D. Yeah, unless you're, I guess it's all millimeters, so that'll be fine.
All right, so now we have a buffer. And then I think we can just do our buffer here. Does that look right?
It does look right.
Distance in millimeters may be used uninitialized.
Oh, because you didn't set it to 0 at the top. Should be fine.
Holy cow, if this worked, Chris, it would be amazing.
I don't know, Mike.
Because we'd be 4 minutes from the end of the live stream. And we'd have
Actually, we
done
didn't put an
something
end
extra.
time. I never put an end time on a live stream. That's the thing. It's always up to the streamers. You gotta put your hand over it, Mike.
Oh, right. Oh, I got to get the. We'll have to go look at it on the
console.
cloud too.
Yeah.
All right.
Oh.
Haha! 6.6. Is that right?
That is right.
66 millimeters. I don't think. Maybe it was 66 millimeters.
You know the hard part about this, Mike?
What's
The
that?
metric system.
I was going to say device. All right. So
Does
we
anyone
went
even
from
understand what 66 millimeters is?
Well, a millimeter is the thickness of your pinky nail, right? And a centimeter is the width of your pinky nail.
That's good.
That's how I do it.
Yeah, that's good.
All right. So we did another reading. This one should be greatly more.
That's basically the extent of the. That's what it gives up, and it says it's more than 1.7 meters away. Mike's ceiling.
That's
is
infinity.
Higher than 1.7 meters. Yeah.
Cool. I gotta say,
right.
I know, we've seen this product work. We work with it all the time. It's still cool.
Yeah. Exactly.
I think it is.
I mean, not only did Mike just enable an entirely new ecosystem onto the Golioth Bluetooth-to-Cloud, which he did, he then enabled the sensor board to be sending. So now ST, you now have your dev board sending to the cloud using Bluetooth. That's pretty cool, I gotta say. We're using a standard gateway as well. It's not like a super custom gateway anything either. So
yeah, that's another pretty neat part of this is that the gateway doesn't care where, as long as you're speaking GAT, the gateway doesn't care
GAT and
what
pouch.
hardware you bring. Yes,
GAT and
yes,
pouch.
of course.
Yeah, and pouches are our protocol that basically gives the headers and the encryption and the all the stuff that we're putting into that pouch. It describes it, and then that's ultimately how then once that transits over BLE GAT, like Mike said, through the gateway up to the Golioth cloud, then how it kind of unwraps that pouch. Basically, that's the headers help it to unwrap the pouch, put it into its proper space as well. All right. We're going to be back doing other boards. I sent Mike, we've ordered 5 boards. I sent 4 of them to Mike, and he graciously accepted. Yeah, we'll be doing more of those here in the coming days and weeks. And hopefully the HDI part is the least troublesome of that. So
after this, I'm going to go and figure out how to access that device tree without a label. And then next week will be easier.
Blog post coming. I'm sure.
That's right. Yeah, incoming.
Yeah. All right. Well, thank you, Mike, and thank you everybody who showed up and all the great questions. We'll see you next time.